Assalamualaikum and hi. Today our group will present about question number 4. The title is Laplace. Alright, before we go further, let me introduce our group member first. So first, my name is Muhammad Asli. Next, AKMAL bin KALAM. Next, Muhammad NAJMI bin MISBAH. And the last one is Muhammad HAFIZ bin YUSLAH. We are from group 4. So today I will present about the introduction of Laplace, manual calculation for question number 4, software calculation for question number 4, and conclusion for this project. Alright, we have three objectives on this project. Objective 1 is calculating a question number 4 using a Laplace method. Next, simulate a question number 4 using a MATLAB software. So on using a software MATLAB. And the last one is comparing answer for the manual calculation and the MATLAB simulation. Alright, for introduction, Laplace is a mathematical tools using an analyzed dynamic system by converting a function from a time domain to the S domain. Next, it simplifies the study of differential equation and allow for algebraic manipulation or transform function. The transform named after a pure Simon Laplace find application in various fields including engineering, physics, and signal processing. By examining a function in a frequency domain, it provides insight into the system behavior and response characteristic. The Laplace transform is a powerful technique for understanding and solving a problem in dynamic system. Alright, this is our manual calculation. So our group got the question number 4, which is Laplace transform. So for A1, the graph here, we need to write the equation first. Yt for yt2, the range is 0, less than equal to t, less than equal to 2. And for yt negative 1, the range we get here, t more than equal to 2. So we simplify on the formula. Yt equal to 2 plus negative 1, negative 2, h 2 minus 2. So, and then yt equal to 2 minus 3h, t minus 2, and Laplace. So yt equal to 2 minus 3h, 2 minus 2. The ys we will get equal to 2 over s minus 3 exponential negative 2s per s. Okay, that is the A1. Alright, for question A2. Alright, for question A2, we have here Fs, S2 plus 5, S, S2 plus 10. So, Laplace transform, Fs, Laplace S2 plus 5, S multiplied by S2 plus 10. So, we simplify here. So, I skip that. So, S2 plus 5 equal to A. This is the rumus here. A for AS plus BS plus C S2 plus 10. Okay. So A S2 plus 10 plus BS plus C equal to S multiplied by S. S2 plus 5 equal to A S squared plus 10A plus BS squared plus CS. So we simplify and we will get the A is negative 1. A is 1 over 2 and B is 1 over 2 and C we will get 0. Alright, after that we need to calculate. So we using the formula S2 plus 5 S2 plus 10, so equal to 1 over 25 plus 5 to multiply by S2 plus 10. So Laplace S2 plus 5 S2 plus 10. So we'll get 1 over 25 plus S2 plus 10. So we can see here, we simplify the equation here. So we will get 1 over 2 plus 1 over 2 cos multiplied by certain t.
For question number 4b, Laplace dit over dt plus 1tr plus 1 over c integrate t0 it dt equal to limit 1 t less than 0, 0 t more than 10. For the value L equal to 1 H, R equal to 0.4 ohm, and C equal to 8F. Laplace dit over dt plus 0.4 it plus 0.125 integrate to 0 it dt equal 1 minus h t minus 10 sis minus I 0 plus 0.4 is plus 0.125 is over s equal to 1 over s minus e to the power of negative 10s over s. I0 equal to 0. So we got Is equal 1 minus e to the power of negative 10s over s square plus 0.4s plus 0.125. By using completing square, s square plus 0.4s plus 0.125 equal s square plus 0.4s plus 0.4 over 2 square minus 0.4 over 2 square plus 0.125. So we got s plus 1 over s square plus 17 over 200. Is equal t e to the power of negative 10s over s plus 1 over 5 square plus 17 over 200. For the Laplace inverse, Is equal 1 over s plus 1 over 5 plus 17 over 200 minus e to the power of negative 10s over s plus 1 over 5 square plus 17 over 200. By using first shifting theorem, it equal e to the power of negative 1 over st, Laplace inverse 1 over s square plus 17 over 200 minus e to the power of negative 10s over s square plus 17 over 200. Laplace inverse 1 over s square plus square root 17 over 200 equal Laplace inverse 1 over s square plus square root 34 over 20 multiply square root 34 over 20 over square root 24 over 20. So we got 20 over square root 34 Laplace inverse square root 24 over 20 over s square plus square root 24 over 20 square. Ft equal 20 over square root 34 sin square root 34 over 20t. For Laplace inverse e to the power negative 10s over s square plus square root 17 over 200 a equal to 10. It we got e negative the power of negative 1 over 5t 20 over square root 34 sin square root 34 over 20t plus e to the power negative 1 over s t minus 10 20 over square root 34 sin square root 34 over 20 t minus 10 h t minus 10.
Right, next part is a software calculation. In software calculation, our group are using a MATLAB software. So there is the coding for every questions, and I will conduct for the coding for question A1. So for question one, first we need to declare first SYMS TS. Next, we define the function. So how to define the function? We put the calculations by y equal to 2 minus 3 multiplied by head beside t minus 2. And after that, we compute the Laplace transform. So how to compute the Laplace transform? The formula is y equal to Laplace y ts. And last but not least, we display the result. So how to display the result? We are using y equal to simplify y.
Okay, next for the coding I2, A2. Firstly, we use the Sims command to define the Laplace domain. and we already get the f, which is the s power of 2 plus 5 over s multiplied by s power of 2 plus 10. And we compute the inverse Laplace transform by using the I Laplace function that have in MATLAB, and we put the display to get the result. Okay, next for the question B. Firstly, we just put the s seems s t as the first chord, and next we state all the values that the component values that have, which is like resistor, inductor, and capacitor, and the others. After that, after we state the value, we also must state the symbol of every component in in the circuit by using MATLAB code. And after that, we use the I Laplace and VPA to get the four decimal places. And we use the display current IT and display IT to get the result.
Right. What can I say is the manual and the software calculation that we have get is the same answer. So to conclude that the Laplace transform is a powerful mathematical tool used in the analyzed dynamic system by converting a function from the time domain to the S domain. Its ability to simplify a complex problem and facilitate algebraic manipulation make it indispensable for understanding and solving problems in dynamic system. The Laplace transform continues to play a critical role in advising scientific knowledge and technology advancement. Alright, I think that's all from us. Thank you for watching.